These are not ghouls, but they do smell the way I think zombies might smell. These are the weirdest, stinkiest fungi on the planet, the stinkhorns. Hey guys, I'm Tasha the Amazon, and you're watching Floralogic. And though this show is called Floralogic, we're actually all about delving into the worlds of both flora and fungi. So let's start our expedition into the world of fungi with one of the stinkiest on the planet, the aptly named stinkhorn mushroom. Mushrooms are universally beloved creatures. They look adorable, they taste delicious, they give Super Mario his powers, but the stinkhorn looks so alien and smells so foul, you would be forgiven for thinking a Demogorgon took a number 2 in your backyard.
Their smell, despite being nauseating to us, is a key part of their reproductive success. Most fungi reproduce asexually by releasing spores, which can then grow into another spore-producing individual. But like plants, fungi have a dispersion problem. How can they ensure their spores travel as far as possible so that the next generation can colonize new areas?
Most spores are very light and can be picked up by the wind, but stinkhorns took a page out of the tapeworm playbook and adapted to be dispersed by animals. This is where the stank comes in.
All stinkhorns secrete a substance called gleba, which is basically smelly spore jello. This gray goop smells like a combination of rotten eggs and putrid meat, which is exactly the type of thing flies love to eat. The flies will eat up the gleba in less than a day and fly off. Some fly species can eat over 1 million spores in one sitting, and the majority of those spores will germinate in the fly's digestive tract.
Gleba also has laxative properties, so after a day, the fly will defecate and the germinated spores will be released. The next part of their development is slowly growing into a ball, or an egg, also called a witch's egg.
These eggs already contain all the compressed components of a fully grown stinkhorn. Some species even produce edible eggs. The common stinkhorn eggs are said to taste like radish. During this stage, they're often mistaken for puffball mushrooms, but if you open them up, you can see a clear difference. Puffballs are usually uniformly white, while a stinkhorn egg's cross-section reveals different tissues of different colors and textures. After a few months in the egg form, they get ready to erect themselves. They pump water into the inner tissue and it expands while secreting gleba to attract flies. Soon after, the external structures break down and its life cycle is complete.
So starting out as an egg and growing into gleba-producing structures are the common features of stinkhorns, but the diversity of ways they do this is amazing.
The most common one is Phallus imputicus, or common stinkhorn, which gets its name from Greek. It means immodest phallus, and it can grow from a 5 centimeter wide egg to a 30 centimeter tall phallus in just 2 days. This guy is definitely a grower, not a shower.
Despite their amazing biology and diversity, stinkhorns are the bane of gardeners and picnic throwers everywhere. They can pop up literally overnight and stink up your entire backyard, and there's no fungicides that can prevent the growth of stinkhorns.
The veiled lady stinkhorn is a weirdly beautiful and apparently delicious fungus. It's found worldwide, but it's most commonly found in Asia, where it's used in stir fries and fancy dishes like bird's nest soup.
In East Asia, it's considered an aphrodisiac. I wonder why.
And in Mexico and New Guinea, it's been used in religious ceremonies. But the coolest stinkhorn is the devil's fingers. This frightening fungus looks like something straight out of the mind of H.R. Giger. Not only do the eggs look like something from Alien, but when they sprout, these massive red tentacle-looking bits burst out of the eggs. When it's sped up, it looks pretty disturbing.
Just don't put your face too close to it. You'll probably be fine, but you'll smell like you were juggling rotten skunks.
The Australian anemone stinkhorn is like a baby version of the devil's fingers, with a few more arms and a deeper pool of gleba. This one is kind of cute in pictures, except for the weirdly bulbous stalk. The basket stinkhorn grows like a large woven sphere. It can be up to 20 centimeters tall. It contains high levels of carotenoids, the compounds that make carrots orange. But we weren't able to verify that they're as delicious. Have you ever seen anything that looks like this? And the adorable dog stinkhorn, one of the tiniest stinkhorns out there. Looks like something out of a fairy tale. Except its name doesn't come because pups like it, but rather because it resembles a doggy's reproductive organ.
There are over 70 more species of stinkhorns. We won't go through all of them, but if you want to see them and smell them, just go for a walk in the woods. There's sure to be some in your area.
And if your day gets ruined by the scent of rotting meat outside your window, just remember, it's the miracle of life. A penis-shaped fungus is making stinky spore soup so that flies will eat it and poop germinated spores in your neighbor's garden.
Hey everyone, we have exciting news! We're thrilled to announce the release of Animalogic's very first book, Strange Creatures. This book dives into the most incredible animals we've ever featured on the show, with each chapter packed with my illustrations and stunning full-color images. It's a fun and engaging way to learn about the animal kingdom, and a perfect tool to spark kids' interest in science. Each chapter breaks down an animal's biology, behavior, and all the coolest facts you need to know about these fascinating creatures. Animalogic's Strange Creatures is a must-have addition to your own library, or the perfect gift for an animal lover this upcoming holiday season. Click the link in the description to check it out. And if you can, order a copy. It would mean the world. Thank you so much, and I hope that you love the book.
They can be dusty, slimy, and downright disgusting with a stench that's unmistakable. They can make your food inedible, your basement unlivable, but they might also save your life. We're talking about everything you ever needed to know about mold. Maybe some stuff you didn't need to know, too.
Let's get down and dirty with funky fungi called mold. The first festering question is, how the heck is mold a fungus? Some fungi grow into mushrooms, while others are single-celled microfungi like yeasts. In the case of molds, these fungi are multicellular microorganisms, so they're more closely related to portobellos, but just very, very tiny and simple.
Molds are made up of mycelium and fruiting bodies of certain fungi. Mycelium are the root-like structures of fungus that are made up of thread-like hyphae. The fruiting body is a structure that's specialized in producing spores for reproduction.
They come in almost every color: blue, white, red, orange, yellow, pink, brown, green, and even the dreaded black.
True to their fungus roots, if you zoom in, molds look like teeny tiny little microscopic mushrooms. Zoom back out, and you'll recognize the hyphae from the fuzzy appearance of that moldy orange on your counter, and the spores from the cloud that comes off of it when you toss it in the compost bin.
The spores that mold releases really get around. They can travel a number of ways: by air, water, or carried by insects and animals. That's why mold can be found pretty much anywhere on the planet, both indoors and outdoors.
Once the spores find an ideal environment like moist, shady areas, they'll set up shop and start multiplying. Most molds prefer decomposing materials. For this reason, molds are an extremely important part of nature's recycling process, breaking down plant and animal matter so those resources can be used elsewhere.
But mold doesn't discriminate, as long as the conditions are right. It can grow pretty much anywhere with moisture, oxygen, and some organic material to consume.
The usual types of mold that are found inside are from the genera Cladosporium, Aspergillus, Alternaria, and Penicillium, to name a few.
They can be good, neutral, or evil in terms of their effects on humans and human endeavors. Let's break down these 4 genera.
Cladosporium, containing over 700 species that we know about, are among the most common species of mold in the world. They're almost completely harmless to humans, though some can cause allergies and asthma. They usually grow on rotting organic material, but can grow inside your refrigerator, causing food spoilage and discoloration.
Cladosporium molds often present themselves as brown, green, or even black. But this isn't the toxic black mold you're thinking about. We'll get to that one in a minute.
On the helpful side of the mold spectrum, we have the species of the Penicillium genus. These molds are responsible for some of the most popular soft and stinky cheeses, like brie, camembert, gorgonzola, and roquefort.
The genus name also gives away the fact that life-saving penicillin is derived from one species, Penicillium chrysogenum, which was previously known as Penicillium notatum. Today, penicillin is a staple antibiotic, but before it was discovered by accident in 1928, people died regularly from all kinds of basic infections. Penicillin works by targeting bacterial cell walls. It disables an enzyme needed to strengthen the walls. The bacteria keeps growing, but without a sturdy wall to support it, eventually swells up, ruptures, and dies. Among Alternaria mold species are some major plant pathogens that have the power to decimate entire crops with black rot. If you've ever seen a squishy brown spot on an apple, an Alternaria species is probably to blame. And yes, one bad apple will certainly spoil the whole bunch, at least when it comes to Alternaria mold, which spreads quickly from fruit to fruit. The greatly feared species known as black mold is Stachybotrys chartarum, and it's had a bit of a PR problem. This mold has been vilified as toxic, but it turns out it's not actually as deadly as it's made out to be. Black mold loves cellulose, aka fibers from plants, so it makes itself cozy in paper, wood, and drywall. Sure, it'll cause sneezing, coughing, congestion, and eye irritation, and make asthma symptoms worse, but this species isn't actually any more dangerous than other types of mold, and it probably won't kill you. When it comes to Aspergillus molds, some can be helpful and some can be extremely harmful. One species causes the disease aspergillosis, which can cause mild to severe illness in people with weakened immune systems. Other species, namely the koji molds, have been used in East Asia for thousands of years in fermentation to create products like soy sauce and sake. Yet other species, Aspergillus flavus and Aspergillus parasiticus, which grow on crops in warm and humid regions of the world, produce dangerous toxic chemicals known as aflatoxins. Aflatoxins can make people and animals very ill. They're the best known and most researched fungal toxin, and are known to cause nausea, vomiting, abdominal pain, and convulsions if ingested. Chronic exposure causes liver damage and cancer. In fact, aflatoxins are considered to be one of the most carcinogenic substances in the world. These aflatoxins come from molds that grow mostly on crops like corn, rice, millet, wheat, peanuts, cottonseed, and tree nuts. To reduce your risk of exposure, it makes sense to buy products from major commercial producers and to ditch any nuts that seem shriveled, moldy, or discolored. One of the most burning questions about mold is it safe to just cut the moldy part off your food and eat the rest? The simple answer is no, not really. By the time the mold is visible on the surface, it means that it's likely already been infested throughout with the mold's invisible root-like mycelium. In the case of dangerous molds, that means that mycotoxins may be present even if the part you're eating looks okay to the naked eye. If you do accidentally ingest something moldy, you don't have to panic though. You're probably just going to be fine. Just monitor yourself for the rest of the day, and if you experience any severe symptoms, like shortness of breath or a fever, seek medical attention right away. From trying to kill you to being used to make life-saving medicine, molds are an unending source of intrigue. With an estimated 300,000 species worldwide, we may never fully comprehend everything molds are capable of. What we do know for sure is that mold is always going to spoil your lunch.
A destroyer of forests, and possibly the largest organism to ever live, even bigger than the giant sequoias. Armillaria challenges our ideas of what it means to be an individual. What makes this parasite such a successful killer that can live for thousands of years? This is the Armillaria fungus, the humongous fungus.
Today we're talking about the largest living organism on Earth and how to catch and eat it.
Nope, we're not telling you to become a whaler and hunt blue whales, or to wear your finest flannel and become a giant sequoia lumberjack.
The largest organism in the world is actually a delicious mushroom, the size of about 1,800 contiguous football fields.
This humongous fungus's real name is Armillaria osteae. Members of its genus are commonly known as honey mushrooms due to their delicious yellowy caps.
Don't get too infatuated with these cuties though. This fungus is a parasitic tree killer that can wipe out forests.
In 1998, Malheur Forest in Oregon was a botanical crime scene. 112 trees had mysteriously died. Investigators scoured the forest, collecting evidence from the roots and the soil. After bringing them back to the lab, they realized the murderer was Armillaria osteae, and that trees as far as 4 kilometers away were being parasitized by the same individual. Further research showed that the fungus was 9.1 kilometers squared, 4 times bigger than the country of Monaco. It is also about 35,000 tons, which is about 250 blue whales. And it was around 9,600 years old.
Once they get to a tree, the fungus spreads root-like rhizomorphs under the bark and around the roots, absorbing all the nutrients. Eventually, the tree dies.
This particular individual has managed to survive this long because the Pacific Northwest has a huge density of trees, and thus a steady source of food. The humongous fungus specializes in Douglas fir, pine trees, and other soft woods. Luckily, their growth is incredibly slow, only a few meters per year, and it can be blocked by planting more resistant trees, such as hardwoods. But when unimpeded, it thrives. The fungus has adapted to consume both live and dead plant matter, so unlike other parasites, it doesn't have a need to keep its hosts alive.
One of the weird things about this mushroom is that it doesn't grow like plants and animals. Instead, it can create clones and then fuse with them into a single organism. Weird. The system works like this.
Armillaria reproduces sexually. The delicious yellow mushroom caps you see above ground release the spores into the air. There are 2 types of spores, which are not technically male and female, but work in a similar way. If the 2 types of spores get in contact with each other, they form into a fungus. If the 2 spores were released by the same fungus, the new individual will have the same genetic makeup and will be technically a clone. It'll grow independently, spreading its mycelia, which, in fungus, are the equivalent of roots.
Most of the fungus mass throughout its life will be mycelia. You might have even seen some of this at home in food that's getting a little old.
If this new individual gets in contact with its parent or another clone, it will fuse with it, becoming just one organism. They continue doing this for thousands of years, and eventually, you get a humongous fungus.
You might be wondering, is a network of fungi really a single organism? The answer is, of course, technically yes.
By definition, an organism is a group of genetically identical cells that can coordinate to do something together. The cells of the tip of the nose of a giraffe are genetically identical to those at the tip of its tail, and so are the cells of the edges of the humongous fungus. The difference is that in the fungus's case, they started in what looked like a completely separate body.
If you're far from Oregon, you can still see these giant fungi all over the world.
If you can, and it's safe, go to your local forest in the fall and look for honey mushrooms. You can tell them apart by the gills under their cap, the ring on their stalk, and the white spores they leave if you put them on a hard surface.
They might not be the same species, but they'll likely be part of a large network of genetically identical mushrooms.
And if you happen to see Armillaria mellia at night, you might even run into a light show, because this species has bioluminescent mycelia.
We can't tell you to eat anything you find in the wild, but if you find these at a store, they're delicious in stir fries and pasta. Let me know your favorite recipe.
This parasite is here to control the minds of its insect victims, with some species turning their hosts into real-life zombies. Once it's taken over, this fungus can turn a formerly dedicated member of the colony into an unwilling Trojan horse. These terrifying brainwashers are cordyceps.
Today we're talking about cordyceps, a not-so-fun guy, at least not if you ask its helpless, mind-controlled victims.
Cordyceps are a genus of over 500 parasitic fungi and can be found around the world, but are most predominant in warm, high-humidity climates in Asia. Their spores enter their victims, insects and arthropods, and set up shop immediately.
If bugs could scream, it would be too late.
Some species of cordyceps use their power of mind control to turn their hosts into walking zombies, hell-bent on doing their bidding.
Nope, this isn't science fiction, it's science scary. But lucky for us humans, these type of mind controllers only prey on people in sci-fi movies and video games.
Some of their closely related fungi cousins, the Ophiocordyceps, take it a step further. For Ophiocordyceps hosts, the relationship with their parasite couldn't be more toxic. As one species, Cordyceps unilateralis, slowly takes over, it instructs the ant to act natural, tricking its colony mates into thinking everything's all right.
That's the fungus equivalent of nothing to see here. Might need to find a better word for it.
Scientists notice that ants' brains are left mostly unaffected, but tissue around the body is often replaced by the fungus mycelia. This means that the fungus might actually not take over the mind, but rather the body of the ant, and forces it to move against the ant's will. They might not be making zombies, they're making live puppets.
In turn, humans have been using cordyceps for medicinal purposes for ages.
For thousands of years, cordyceps have been used in Chinese and Tibetan traditional medicine. Cordyceps sinensis, for example, is a medicinal species that sprouts exclusively from the head of ghost moth caterpillars and is only found at high altitudes in the Qinghai Tibetan Plateau. Because of its rarity, it's prized as one of the most valuable ingredients in these medicinal traditions.
Instead of zombies, this cordyceps took a page from a different horror novel and turns its victims into mummies.
The resulting fungi host complex is then used for a variety of ailments like asthma and respiratory inflammation. Overharvesting of this species has put it on the endangered species list in China. Cordyceps militaris, which is much easier to grow commercially, is often used as a cheaper alternative.
One thing's for sure, mind control is not one of the side effects of cordyceps. At least not outside of science fiction.
Humans are also finding ways to put cordyceps to good use outside of medicine. Currently, cordyceps are being investigated as eco-friendly pest killers for a variety of invasive baddies.
So in a way, cordyceps are basically Dexter.
Citrus crops, for example, are attacked by citrus leaf miners. While these pests have traditionally been effectively managed with the application of synthetic insecticides, the flip side is that these same chemicals have a big negative impact on predators and other insects.
A lack of predators means it's basically open season for other harmful pests to come to the citrus feast.
Introducing Cordyceps javanica, which parasitizes leaf miners, to the citrus battlefield, is one way researchers are combating these pests naturally. In the fight against coconut root grub, which attacked the roots of coconut and other crops, spraying the ground with insecticides isn't a healthy option for anyone. So scientists are investigating species like Cordyceps militaris that naturally prey on these grubs to control their populations.
From parasitic killer to medicinal healer, cordyceps really do have so many layers. But are they layers of a parfait or layers of an onion? I'll let you be the judge.
These extinct terrestrial giants are one of the most enigmatic we've ever discovered. They stood as tall as streetlights, only much wider across, and were peppered across the land on every corner of the planet. Nope, I'm not talking about dinosaurs or giant mammals. I'm talking about absurdly enormous ancient mushrooms. These are the Prototaxites.
Today we're unearthing some seriously fantastical fungi that have been hotly debated since their discovery. Let's dig into Prototaxites.
Prototaxites were enormous fungi that dominated the landscape during the Devonian period. These telephone pole-like fungi ranged from 2 to 9 meters tall, and some were as big as 1 meter across.
Prototaxites were found on land all over the planet, but at the time, the continents and landscape looked a lot different.
For most of the Devonian period, Today's North America, Greenland, and Europe were united into a single landmass called Laurasia, or Euramerica. Today's South America, Africa, India, Australia, and Antarctica formed another supercontinent called Gondwana.
The Devonian period spanned 60 million years, beginning 419 million years ago. It's best known as the Age of Fishes, since most life on Earth still existed in the water at this time.
85% of the planet was covered in oceans during the Devonian, compared to today's 70%. And the little land that did exist didn't have much going on. Slowly but surely during this period, the formerly barren land started to become populated with small plants that would eventually evolve into the massive trees and vegetation we know today. The only land creatures were small invertebrates like arthropods, wingless insects, and early arachnids.
The barren landscape, low-to-the-ground plant life, and lack of large creatures would have made Prototaxites stand out like a bunch of freaky sore thumbs.
These ginormous fungi would have been the tallest living things on the land, quite literally towering over everything else. It wasn't until the Middle Devonian period when other large plant species started to evolve, and these landscape-dominating giant fungi started to slowly fade into oblivion.
Until recently, we didn't even know for sure that Prototaxites were actually fungi. This species has been the source of debate since its discovery. And trust me when I say that debates can get heated in the paleobotany department. Shade has been thrown. The aggression has been positively passive.
It all began with geologist J.W. Dawson, who, in 1855, began to study a collection of fossils that had been dug up in Gaspé Bay, Canada, more than a decade earlier. Among them was one of the strangest fossils he'd ever seen. Because of the sheer size of the specimen, which would have stood 6 meters high and was half a meter across, Dawson named it Prototaxite.
This name, meaning early yew, was a nod to the fact that Dawson believed this strange fossil to be a coniferous tree.
He explained away the loosely organized tissue and meshwork of root-like fungal structures by claiming this particular tree was rotting when it became fossilized, and so began a ruthless, decades-long, sciencey beef.
In 1872, paleobotanist William Carruthers ripped apart Dawson's theory, arguing that geologists who dominated the field of paleontology didn't know enough about plant morphology and characteristics to make any kind of judgments. Burn!
Based on what he saw, Carruthers insisted that the giant specimen was clearly some kind of marine algae, despite evidence that it definitely grew on land. In a paleobiological FU for the ages, Carruthers renamed it Nematophyton, meaning filamentous plant.
In response, Dawson clapped back. Quote, "The tone and manner of the article, I may say in passing, are unnecessarily offensive, and the author bolsters up his argument by unfair assumptions that I am ignorant of some of the most familiar facts of structural botany. Facts which were well known to me while he was yet a schoolboy." Unquote. The lesson here, never tick off a scientist unless you're ready for some seriously scholarly burns.
Despite Dawson's counter-arguments, Carruthers' interpretation went largely unchallenged until 2001, when it was proposed that Prototaxites were actually fungi. In 2007, using isotopic analysis, this shroomy theory was confirmed.
Prototaxites were indeed most likely enormous mushrooms. We know this because plants only absorb carbon from the air around them, meaning that all plants analyzed during a specific time will have similar levels of carbon. Animals, on the other hand, get carbon from what they eat, so will have similar levels to whatever it is they're consuming. Fungi get their carbon from the nutrients they absorb through their root-like mycelia. The carbon in Prototaxites show they have different carbon levels than the plants around them, which proves they were not plants.
Like many fungi today, one theory is that Prototaxites got their nutrients from breaking down and absorbing dead and decaying matter in the ground, likely from the small plants that blanketed the ground around them.
The size of Prototaxites would suggest that their mycelium networks would have had to be enormous to support such huge structures.
Their giant size begs the question, what's the point in being so tall if you're not competing with anything else for resources? One theory points to how fungi reproduce, by throwing spores into the air and letting the wind take them. The logic here is that the taller the fruiting body which releases the spores, the further the wind can take them to populate far-flung areas.
Okay, so if they were so good at reproducing, where are all the Prototaxites today? There are a few theories as to why we don't have enormous mushrooms towering over our current landscape.
We know that Prototaxites became extinct towards the end of the Devonian period. It was at this time that vascular trees and shrubs started to evolve and overtake the land, probably outcompeting the prototaxites. Terrestrial insects and animals were also further evolving at this time. Specimens of prototaxites have been found with insect and arthropod boreholes, so other theories suggest that being snacked upon, combined with slow regeneration, could have also led to their ultimate demise.
While most scientists today agree that prototaxites were indeed fungi, the debate about what kind of fungi and how they survived for tens of millions of years still rages on.
This unassuming fungus kills more people than any other mushroom. Eat one of these and your days are numbered. But before you die, you'll first have to suffer for days, if not weeks, as your liver slowly fails and your organs give out. This is the appropriately named Deathcap mushroom.
Today we're talking about a super deadly fungus that's invaded almost every corner of the world. Amanita phalloides, otherwise known as deathcap mushroom, is a species of highly toxic mushrooms of the Amanitaceae family. And when I say highly toxic, I mean this little not-so-fun guy is responsible for about 90% of mushroom-related deaths in the world. It's kind of inspiring how much deathcap mushrooms have managed to grow their kingdom.
The fruiting bodies of deathcaps go through many looks in their short autumnal lifespan. When mature, the caps can range from greenish yellow to brown, all the way to tan or sometimes white. These caps can be as small as 4 centimeters or as large as 16 centimeters and can be round or oval when young and convex or flat as they mature.
Just like humans, young deathcaps smell really wonderful, but get stinkier with age. Those who've eaten them and lived to tell the tale say they're actually quite delicious.
It's important to note that they are as toxic as plucky youngins as they are when they're glimmering old daddies. So regardless of their taste or odor, they will kill you the same at any stage of their maturity.
We used to believe that these unassuming mushies were native to every continent but Antarctica. Recently, however, thanks to DNA evidence and some serious botanical sleuthing, we've discovered that deathcaps are actually native to Europe and the British Isles.
And much like the British, they've invaded and colonized almost every other part of the world. Deathcaps accomplish this not of their own will, but rather as stowaways in the roots of trees like oaks, birches, and elms that were transplanted from Europe.
In other words, they were unwittingly spread around the planet by the very species they're easily capable of murdering.
Deathcaps are mycorrhizal, meaning that they have a symbiotic relationship with plant roots. Mycorrhizal mushrooms use their root-like mycelium to tap sugars from the roots of their host tree. But since this is a symbiotic relationship, the mushrooms also give back in the form of nutrients like phosphorus and nitrogen that they pull from the soil. These nutrients can actually make the tree more drought and disease resistant, so that's a win for the mushrooms too.
Okay, so how can a fungus that's so beneficial for one species be deadly to another?
Deathcaps contain 3 different types of people-killing toxins, the most deadly of the trio being an amatoxin called alpha-amanitin. This powerful toxin most notably causes liver failure, and because it's heat stable, cooking the deathcap doesn't make it any less deadly.
And amanitin is seriously twisted. It doesn't start doing its worst on your system until 24 hours after ingestion. 6 to 12 hours after eating a deathcap, you'll feel horribly sick to your stomach with nausea and diarrhea. After that, you might start feeling better, thinking the worst is behind you. But this honeymoon period is just the amanitin being absorbed by the lining of your intestines and making its way to your liver.
From 24 hours to 7 days after ingestion, on a molecular level, these toxins scramble the functions of liver cells, which in turn causes the liver to die. In addition to liver failure, you may also experience kidney failure, brain dysfunction, and even death. Quick treatment is essential to save your life. Act too slowly, and within a week, you might just be a goner.
The reason that deathcap poisoning is so darn hard to treat is because amanitin is sticky. The patient may be given activated charcoal and IV fluids to try and counteract the effects of amanitin, but once the toxin binds to the liver cells, there's basically no going back. If the patient is stable, a liver transplant may be the only way to save their life.
A compound called Psilocybin can be used to head off the effects of amanitin, since it binds to the same liver receptors and prevents the amanitin from getting its hooks into the liver cells. Psilocybin, however, is only effective when taken before the amanitin has had a chance to bind, which means you'd have to take it before symptoms even set in. That means you'd have to know for sure that you ate a deathcap instead of a harmless edible dupe.
Mistaking a deathcap mushroom for an edible lookalike is actually what leads to the majority of poisonings every year. As I mentioned, deathcaps can look very different depending on their stage of their life cycle, making identification hard and causing confusion with other harmless and even delicious species.
Volvariella volvaceae, or the paddy straw mushroom, which is cultivated throughout East and South Asia and is used widely in cooking, looks suspiciously like these deadly shrooms. Before their caps erupt, young deathcaps have a rounded appearance and can also be mistaken for edible puffball mushrooms, which are found in temperate climates around the world. Then, there are several edible mushrooms in the Agaricus genus, which contains culinary favorites like button and field mushrooms that can also be confused with young deathcaps.
While highly lethal, the deathcap isn't the only baddie in its Amanita genus.
Amanita muscaria, otherwise known as fly agaric, fly amanita, or colloquially toadstool, is probably the most recognizable mushroom in the world. Anyone who loves the Super Mario franchise will know this red and white icon. This species is poisonous, and while it has the ability to kill, it rarely does. Unlike deathcaps, Amanita muscaria attacks the central nervous system, sometimes leading to coma. Luckily, this Amanita species stands out like a sore thumb, so confusing it for another fungus is pretty rare.
There are a few other extra baddie species in the Amanita genus that aren't as easily identified as a red and white speckled toadstool.
These Amanita are commonly referred to as destroying angels due to their ethereal white appearance and potent killing powers. There's Amanita virosa, a European native, Amanita bisporigera, native to eastern North America, Amanita ocreata, native to western North America, and the European Amanita verna.
All of these highly deadly fungi have a similar effect as deathcaps. A single mushroom topper of these destroying angels can end you.
Immature destroying angel mushrooms commonly look a lot like other species that are edible. So, like deathcaps, accidental poisonings have also been known to happen.
Given all that toxicity, I'm here to assure you that not all Amanitas want you dead. Some are perfectly edible and delicious.
Amanita calyptoderma, otherwise known as cocora or cocoli, looks eerily similar to deathcaps, but is 100% less deadly. Amanita caesarea, otherwise known as Caesar's mushrooms, are equally delectable.
Then, of course, there is Amanita vaginata, commonly known as the grisette, which is excellent for eating.
Despite the gloomy diagnosis after eating a deathcap, there is hope on the horizon for ingesters of this deadly fungi. A new compound that's already been in use in the medical field, an imaging dye called indocyanine green, has been found to block the effects of alpha-amanitin.
So far, we have yet to test this compound on humans, but perhaps with more research we can prevent the estimated 100 deaths a year that deathcaps are responsible for.
This trendy superfood isn't news to the indigenous groups that have been using it for thousands of years. If you look past all the hype, you'll find a fungus with enormous potential to even cure cancer. But buyer beware. For all its benefits, this fungus is at risk of being over-harvested unless we find a sustainable way to grow it. This is Chaga.
Today we're talking about a cure-all that might actually cure all. Chaga, otherwise known as birch conch, cider conch, and clinker polypore, which actually kind of sounds like the name of a rich old guy wearing a monocle.
Inanatus obliquus is a parasitic fungus of the Hymenocataceae family that grows mostly on birch trees, but less commonly on other hardwood trees like oak, poplar, ash, alder, and maple. Chaga can be found in the northern hemisphere and grows in Canada, the US, as well as Europe and Asia.
While some like it hot, Chaga likes it cold. The colder, the better. Chaga thrives especially when its host tree has to endure a lot of stress due to extreme temperature changes, going from warm in the summer to frigid in the winter.
Chaga grows between 10 and 20 centimeters wide and looks burnt and crumbly on the outside, but is orangey brown on the inside. The outside actually contains lots of melanin, which is why it sports this distinctive black hue. This high melanated fungus sprouts when its spores come into contact with an injured part of a host tree, allowing easy access to the tree's heartwood.
The chaga will keep growing as long as the tree is alive, but with this parasitic fungal infection, the tree's days are already numbered. That's because the chaga causes the heart to rot, eventually killing the tree in 10 to 80 years. But why kill the tree at all? Lots of other parasitic species keep the host alive, so they don't murder themselves out of a free ride. It kills because the chaga needs the tree dead to move on to its next life cycle.
The black, crusty part that you see while the tree is still active is actually the asexual form of the chaga, otherwise called sterile mycelial masses. This part doesn't have any spores and can't make new baby chagas.
The sexual form, otherwise called the fruiting body, appears between the bark and sapwood as a yellowish crust that turns brown 2 to 12 years only after the tree dies. It's from this fruiting body that the spores will take to the wind to find new injured trees, and the life cycle of the chaga continues.
If you Google the word chaga today, you'll be inundated with pills, tinctures, teas, and powders promising a wealth of health benefits. Though chaga seems to be the hottest superfood on the internet, snowballing in popularity over the last decade or so, many foraging cultures have already been using chaga medicinally for thousands of years to treat an array of ailments.
The Khanty people, an Urgic indigenous people from Siberia, for example, have long been using chaga to treat parasitic worms, tuberculosis, and digestive problems like gastritis and ulcers. They even use chaga as preventative medicine for heart and liver disease.
The Khanty people administer chaga in one of 3 ways: as a tea, inhaled as smoke, and as soap water.
The soap water is made by burning the chaga and placing the smoldering charcoal into hot water and stirring until it breaks down. This water has been used to clean hands and feet, in the ritual cleaning of women after menstruation, and of newborn babies after birth.
Indigenous peoples across Canada and the US, along with other cultures around the Northern Hemisphere, have also been using chaga in traditional healing for thousands of years.
Chaga is chock full of vitamins, minerals, and nutrients, like antioxidants, amino acids, and plant sterols, which is like the plant version of cholesterol. Since chaga is a parasite on birch trees, it actually sucks all of these good nutrients out of the tree, making them available to humans who harvest the fungus.
Okay, check this out. Here we got chaga mushroom. I'm gonna drink it, and it's not gonna make me a crazy person like coffee does. Scooby-Dooby-Dooby! Crazy. Check this out. That, you liking the look of that? And then we just have a little squirt. Easy as 1, 2, chaga. Oh yeah. Oh yeah. Ow! So I put some cubes in. And then I put some plant-based things that are pretending to be milk in it. Give it another little stir. And I'm gonna drink chaga. I'm gonna drink chaga. Delicious and also nutritious. Let's talk more about it. So far, over 200 compounds have been extracted and identified from chaga. But the recent popular interest in this fungus has proven to be a double-edged sword.
On the positive side, chaga is being investigated for use in mainstream medicine. Initial studies have shown chaga has potential as an antioxidant, which are molecules that fight off harmful free radicals in the body that can cause health conditions like cancer. Chaga is also being investigated as an anti-diabetic, since it's been preliminarily shown to lower blood sugar. On top of all that, this fungus also seems to curb inflammation and is being tested for its powers as an anti-inflammatory.
Part of the reason everyone is gaga for chaga is because of its promise in the battle against cancer. Chaga has been widely reported on for its anti-cancer activity, though according to the records, even this isn't a new revelation.
A tale from historical chronicles claims that a 12th century Ukrainian prince's lip tumor was cured with the use of chaga. With cancer being one of the leading causes of death worldwide today, it's no wonder that researchers are delving deeply into any promising anti-cancer treatments.
Because of this growing interest, both in medicine and as a superfood, we have to talk about the other side of that double-edged sword: overexploitation and commercialization of this fungus.
Commercial harvesting practices with a lack of understanding of the nuances of chaga growth can have very dire ecological consequences. The slow growth of chaga over decades means it's vulnerable to overharvesting.
On top of that, since the fruiting body that releases the spores to create more chaga doesn't even appear until years after the tree has died, overharvesting before this stage will mean that the fungus cannot multiply at all.
And because chaga is a parasite and needs an adult host tree to grow, that makes cultivation outside of existing mature forests extremely difficult.
One logical solution would be to select the fastest maturing and most aggressive strains to produce chaga faster. But this threatens to throw everything out of its fine balance if this souped-up strain of chaga was unleashed on the forest ecosystem. So while farmers are already looking for sustainable ways to grow chaga, currently its future in the wild may be in question if harvesting is left unchecked. So maybe the real cure we need to look for within this crusty fungus is the cure for human greed.
These fungi have been giving us humans mind-expanding trips for millennia. They grow all over the planet, but are illegal almost anywhere you go. During the Spanish Inquisition, they were even denounced as a tool of the devil. But today we know there's much more nuance to these magical mushies. This is the psilocybin mushroom.
Today we're taking a trip with the world's most fantastical fungi, psilocybin mushrooms. Better known as magic mushrooms, mushrooms, or shrooms.
Psilocybin mushrooms actually refer to about 200 different species of mushrooms that grow all over the world.
When eaten, psilocybin mushrooms cause a psychedelic effect that's experienced as hallucinations, euphoria, altered thinking, and changes in perception and mood.
The compound in magic mushrooms that make them so magical is their namesake, psilocybin. Once ingested, the liver converts this compound into another called psilocin. Psilocin molecules are almost the exact same shape as serotonin, the neurotransmitter that regulates mood. Because they're so similar, psilocin can dock itself into the serotonin receptors in the brain, causing euphoria and all the other common psychedelic effects I mentioned.
Fungi are the primary source of naturally occurring psychedelics in the world, and the most potent of them belong to the genus Psilocybe.
Despite the power they pack to send you sailing on a riverboat ride through your own mind, these little brown mushrooms are quite understated at first glance. But bruise or crush them, and most species of this genus will turn a characteristic deep blue.
I'm not gonna lie, seeing a mushroom turn blue sounds like what happens after you eat these psychedelics.
To fathom hell or soar angelic, just take a pinch of psychedelic, wrote psychiatrist Humphrey Osmond to author Aldous Huxley after coining the term in 1956. The word psychedelic comes from the Greek psyche, for mind, and delos, to show. And that idea of looking inward has fascinated us humans for millennia.
Indigenous communities in the Americas have been using psilocybin mushrooms for thousands of years in traditional practices and for medicinal purposes. The Aztecs called these sacred mushrooms astonishing gifts from the gods.
During the Spanish Inquisition, which began in 1478 and was created to enforce Catholic orthodoxy, all cultural practices involving indigenous belief systems were outlawed in lands that Spaniards invaded. They promptly mistranslated the Aztec name to flesh of gods, and these sacred mushrooms were instantly declared blasphemous and a tool of the devil.
This gift of the gods was forced underground for hundreds of years, yet another victim of violent colonialism.
Its common use today is similarly thanks to exploitation, but this time it came about through cultural appropriation. Mainstream popularity of mushrooms began after the publication of a Life magazine article in 1957 by a former banker that detailed the sacred mushroom rituals of the Mazatec people of Mexico.
Despite promising his guide that he wouldn't share the secrets of that ritual, he published anyway, and interest in this hallucinogenic mushroom instantly spiked.
Just 2 years later, Sandoz Pharmaceutical had isolated, synthesized, and patented the extraction process of psilocybin.
That Life magazine article, which actually coined the term magic mushroom, inadvertently made psilocybin mushrooms an instant counterculture success, beloved by the hippies of the 60s.
This then directly led to mushrooms being included in the Controlled Substances Act of 1970 in the United States, and being classified a Schedule I drug. Schedule I, which includes heroin, LSD, ecstasy, and marijuana, means that magic mushrooms are characterized as having high potential for abuse with no medicinal use.
Despite being classified as a Schedule I drug, it's difficult to overuse mushrooms, and physical and psychological dependence are essentially unheard of.
Mushrooms have low toxicity and are generally well tolerated. A 2016 study found that of 12,000 users, only 24 reported having to seek emergency medical care after taking mushrooms.
Overdose for some drugs means death, but in the case of shrooms, overdose can be described as a very, very bad trip.
Expect intense and terrifying hallucinations, panic attacks, vomiting, diarrhea, paranoia, and sometimes even psychosis. An overdose usually lasts 6 to 8 hours, but can take upwards of several days to completely fade. Like all hallucinogens, tolerance is built quickly, so the more you take, the more you'll need to take next time to experience the same result. This increases the risk of overdose, since the potency of mushrooms can vary.
Actually, the biggest risk in taking shrooms is accidentally ingesting a poisonous species, which outnumbers psilocybin-containing mushrooms about 10 to 1.
While other toxic mushrooms may also give you a trip, they can cause anything from gastrointestinal distress to kidney failure, depending on the species.
The long and the short of it is that mushrooms will probably not be the cause of your untimely passing. In fact, they may even help terminal cancer patients cope with the knowledge of their impending death.
Researchers at Johns Hopkins Medicine compared the psychedelic and near-death experiences of 3,000 people and discovered these people all had similar positive feelings about death. Both groups reported gaining personal and spiritual meaning, as well as psychological insight after their respective experiences. Those results dovetail nicely with another recent study that showed that a single treatment with psilocybin in patients with life-threatening cancer created long-term decreases in depression, anxiety, and fear of death, and increases in death acceptance.
This is just the beginning of promising research looking into the treatment of a range of mental health issues using psilocybin.
Attitudes toward this banned fungus are starting to shift as governments begin to embrace the potential medicinal and therapeutic benefits of psilocybin mushrooms. In the US, for example, psilocybin mushrooms have already been legalized in Oregon and Colorado. A handful of countries around the world also have a range of laws legalizing or decriminalizing mushrooms, while others have laws in place that are essentially unenforced.
Though they may sound like something from a Tolkien novel, magic mushrooms are not as mythical as their name implies and can be found quite easily around the world.
Two species of magic mushrooms, Psilocybe cyanescens and Psilocybe allenii, for example, love wood that already has most of its nutrients removed. This means they frequently pop up right under people's noses in the wood chips of urban gardens in the US Pacific Northwest.
These species have been called synanthropes, organisms that love places built by humans for humans. And given their long history of use, I have a feeling magic mushrooms are going to keep accompanying us on our trips.
Waxy white, as translucent as a ghost, and covered in scales. This paranormal parasite looks as ghastly as it acts, as it saps the nutrients from unsuspecting mushrooms. It doesn't need the light, so it's often found in the deep, dark woods with other fairy tale monsters. This is the ghost plant.
Today we're talking about a spooky specter of a plant that lives in the deepest, darkest, moistest forests of the Americas and Asia, Monotropa uniflora, otherwise known as ghost pipe, Indian pipe, or ghost plant.
The ghost plant's scientific name, Monotropa uniflora, is a real mishmash of classical languages. Monotropa from the Greek for one turn, and uniflora from the Latin for one flowered. One turn, one flowered basically describes the fact that each stem only has a single odorless flower.
But what the scientific name blatantly ignores is that this plant is spooky to the armpits. How do you say creepy as hell in Latin?
Let's start with its looks. This plant is a ghostly translucent white, or sometimes pink, that develops black spots as it ages. It's a perennial, ranging in height from 10 to 30 centimeters and commonly grows in clusters.
Dare to venture out where it lives and pick a bunch, and it'll turn from shimmering white to goth black right before your very eyes.
Because it's so delicate and looks like frozen jelly, the ghost plant is sometimes also called the ice plant because it seemingly melts away when picked up and handled.
So if you're hoping for a snowy white bouquet of ghost plants to haunt your credenza, sorry to disappoint.
The ghost plant's stem is covered in scaly modified leaves called bracts. If you think you've never heard of a bract before, you may know them better than you realize. You might even decorate your home with bracts every December.
The flowers of a poinsettia are actually a bunch of bracts that are more fabulous than the true flowers themselves.
The flower of the ghost plant nods downward until it's pollinated by an insect, at which point it points upright. Bumblebees are the typical pollinators, and they get a sweet nectar and some yummy pollen as a reward for their visit. After it blooms, it goes dark, and the flower is replaced with a seed capsule full of tiny, wind-dispersed seeds. The root system of the ghost plant is brittle and fleshy.
The roots are also apparently very tasty to grizzly bears, who've been seen digging them up for a nice snack.
The ghost plant is in the Ericaceae family, otherwise known as heaths or heathers, depending on your preference. Famous members of this family of over 4,000 include blueberries and cranberries. While it may be related to your favorite yogurt toppings, the pale color, downturned flower, and firm, fleshy texture of the ghost plant often lead people to falsely assume that this plant is a mushroom.
While not a fungus itself, fungi do play a key role in how ghost plants get their nutrients. So the connection with fungus is not that far-flungus.
Which brings us to the creepy as hell way it gets its nutrients. The ghost plant is one of 3,000 heterotrophic plants, which need to rustle up their nutrients from outside sources.
And heterotrophs do just that, but in very uncanny ways.
Insectivorous plants, like Venus flytraps, butterwort, sundew, and pitcher plants, which we've talked about on the channel, catch and digest bugs for nutrients. Parasitic plants, like dodder, sap their nutrients from a host plant. Like dodder, the ghost plant is a parasite, and it lacks the chlorophyll necessary to make its own food from sunlight. The ghost plant was once thought to be a saprophyte, a plant or fungi that eats dead or decaying matter. But new research has found that instead of feasting on the dead,
ghost plants take a very vampiric approach, sucking the nutrients from unsuspecting fungi.
These are mycorrhizal fungi that live around the bases of trees in the deep, dark woods where ghost plants are found. In fact, almost all terrestrial plants have root-infecting mycorrhizal fungi. They live in what's called mutualistic symbiosis. The plant gives the fungi nutrients through its roots, and in turn, the fungi enable the plant to increase its nutrient and water absorption capabilities.
The relationship between fungi and ghost plants, however, is anything but mutual.
The ghost plant catfishes the fungi, tricking it into thinking it's entering another legit symbiosis. But this relationship is a toxic one, since the ghost plant doesn't give anything back. It just siphons off the fungi's hard-won nutrients and energy, like the parasite it is.
If only ghost plants were as nice to fungi as they are to bumblebees.
So the tree does the photosynthesizing, the fungi absorbs the nutrients from the tree's roots, and the ghost plant steals them from the fungi.
And they do it all without lifting a single bract.
Ghost plants are so delicate that propagating them at home is next to impossible. They rely entirely on a specific climate, dark and moist conditions, and, of course, the tenuous love triangle between the tree and its fungus.
No matter how many times you criticize it for wearing white after Labor Day, you'll never be able to throw enough shade at this spooky parasite to make it thrive outside the forest.
Foraging for mushrooms is an extreme sport. It may not be physically tough strolling through the forest looking for fungi, but it can be as dangerous as jumping off a mountain in a wingsuit. Make one small error of judgment, and you could be dead. Which mushroom will become a delicious meal, and which will end your life? Let's dive into the world's deadliest mushrooms. Today we're plucking through the list of the most lethal mushrooms on the planet. There are currently about 14,000 known species of mushrooms. Of those, around 10% are considered edible, and most of the rest are inedible. The term inedible means they can be anything from straight up gross tasting to just giving you a mild tummy ache. The remaining 1 to 2% of mushrooms are considered toxic. That means that they contain toxins that do a number on the human body, causing serious damage at best and death at worst. Hundreds of people a year around the globe die from eating toxic mushrooms. So, which ones are going to send you to an early grave? Let's go in with a bang and start with the most lethal of them all. This notorious mushy is responsible for the vast majority of toxic mushroom deaths a year. Amanita phalloides, otherwise known as deathcap mushroom, is the deadliest mushroom in the whole wide world. It takes less than a half a cap of this unassuming mushroom to spell the end for a strapping adult. The life-ending powers of deathcaps have been known to us for thousands of years. Roman Emperor Claudius, by all accounts, was killed with a dose of deathcap in 54 AD by his fourth wife Agrippina, to make way for her son Nero to ascend to power.
Identifying deathcaps can be tough because they go through so many changes during their short lifespans in the autumn. In their young button phase, they can be mistaken for edible varieties. They've been confused for harmless paddy straw mushrooms and even juvenile puffballs. Deathcaps ooze with 3 different types of lethal toxins. The most deadly of them all, called amatoxin, causes liver failure, which can lead to death without swift action. Amatoxin isn't just contained in deathcaps, but a number of other deadly shrooms, and is responsible for 95% of mushroom-related deaths every year. Unfortunately for us humans, amatoxin is heat stable, so cooking these toxic fungi won't make them any less deadly. Amatoxin poisoning isn't a quick death either. Think slow and agonizing. 6 to 12 hours after ingestion, you'll get nausea and diarrhea. You may then start feeling better, thinking that the worst is behind you. But this short reprieve is just the amatoxin being absorbed by the lining of your intestines and making its way to annihilate your liver. From 1 to 7 days after ingestion, these toxins scramble the functions of liver cells on a molecular level. In addition to liver failure, you may also experience kidney failure, brain dysfunction, and even death. Quick treatment with activated charcoal and IV fluids before the toxins make it to your liver is a must. A compound called psilocybin, which plugs up the liver receptors that the amatoxin will eventually attack, can be effective if taken before the toxin makes it to the liver. Ultimately, a liver transplant may be the only option to pull you back from the brink of death. Recently, an imaging dye called indocyanine green was found to block the effects of amatoxin. So there's at least some hope that one day, the vast majority of these mushroom deaths will be avoidable. In its Amanita genus, the deathcap isn't the only killer that packs amatoxin. There are a few species in this family known as destroying angels due to their ethereal white appearance and ability to kill. Much like the deathcap, these types of mushrooms can be easily mistaken for edible varieties, like meadow or button mushrooms, which is really what makes these destroying angels so destructive. There's European native species Amanita virosa and Amanita verna, Amanita ocreata, found in western North America, and Amanita bisporigera, native to eastern North America, which is North America's most lethal shroom. Despite what the name suggests, Amanita isn't the only fungus genus that hosts amatoxin killers. There are other genera that are chock full of amatoxins too, like this next amatoxin-packed mushy that stole my supervillain name. The deadly dapperling, also known as Lepiota bruneo incarnata, can be found in Europe and parts of Asia. Like other amatoxin killers, deadly dapperling is highly dangerous for the human liver. Its inconspicuous appearance leads it to sometimes be accidentally mistaken for edible mushrooms like grey knight and fairy ring champignon. Galerina autumnalis is a tiny brown fungus that grows on rotting wood and also packs an amatoxin punch. When it's ingested, it's usually confused with the edible Armillaria gallica, aka honey mushroom, or Flammulina volutipes, otherwise known as velvet stem mushroom. This one also looks a lot like Psilocybin species, aka magic mushrooms, so that's another reason why this one inadvertently goes down the hatch. Another magic mushroom dupe, Conocybe phalaris, is another demure-looking lawn mushroom native to the Pacific Northwest. It has a similar MO as the other amatoxin-containing fungi, a slow and painful march to the grave. You would think toxic Amanita muscaria, otherwise known as fly agaric, fly amanita, or the super recognizable toadstool, would contain liver-destroying amatoxin too. But nope. This is one mushroom species that contains different toxins that are equally hellbent on human destruction. Toadstools are overflowing with asoxazole toxins, which attack the central nervous system and can send those who eat it into a coma. While highly deadly, toadstools actually rarely kill. This is probably because their red and white spotted caps serve as an adequate warning to stay the heck away. No one is going to mistake a warning light red toadstool for a harmless mushy. In addition to being toxic, toadstools are also psychoactive. So while you're on your way to seizures, coma, and maybe death, you may also experience hallucinations and delirium. In the Cortinarius genus, there are 2 species native to Northern Europe, deadly webcaps and fool's webcaps, that will do you in. They look suspiciously similar to other edible mushrooms, specifically the coveted winter chanterelle. So poisoning happens more than you'd hope. The toxin in these webcaps is called oralanin, which can take upwards of 3 weeks to show symptoms. By the time you have a proper diagnosis, it's already too late, and the damage to the kidneys is already done. You'll likely need a kidney transplant to survive. If left untreated, death will surely come a-knockin'. Podostroma cornudomei is a rare Asian fungus of the Hypocreaceae family that contains trichothecene mycotoxin. Its unusual appearance leads it to sometimes being misidentified as antler Ganoderma lucidum or even young cordyceps. The lethal toxin contained within this freaky-looking shroom can cause multiple organ failure. Symptoms of poisoning from this fungus are as spooky as it looks. Aside from the usual stomach pain, it also causes peeling skin, hair loss, liver necrosis, acute kidney failure, and ultimately death if left untreated. Nightmarish. False morels, like the species Gyromitra esculenta, look a lot like the wonderfully delicious true morels. But this fake species contains the toxin gyrometrin, which when metabolized by the body becomes monomethylhydrazine, aka a toxic ingredient used in rocket fuel. While it will make you sick as a dog, death from eating this species is extremely rare. As a side note, you need to be careful when eating true morels too, since they can also make you sick to your stomach. Make sure they're thoroughly cooked before eating them and don't eat too many all at once. The fact that mushroom poisonings occur at all only speaks to our obsession with these delicious and sometimes psychoactive little fungi. If you're not a fan, you'll probably insist that 100% of mushrooms are inedible. If that's you, you may never know the pleasure of a fungi pizza, but you'll also never have to worry about an accidental mushroom death. It's not a plant, it's not an animal, it's not a fungus either, though it has been known to act like one. It's not even a mold, despite its name. This creeping goo is older than the dinosaurs and is proof that you don't need a brain to be smart. These are slime molds.
Today we're talking about the ooziest organisms of them all. No, I'm not talking about Slimer from Ghostbusters. I'm talking about ooey gooey slime mold.
Slime mold is in a category all of its own, since it's not a plant, animal, or fungi. It's actually technically an amoeba that lives in the soil. Amoebas are any single-celled organisms that have the ability to crawl, but different amoeba species aren't necessarily super closely related to each other.
Generally speaking, all amoebas, including slime molds, are enclosed by a cell wall and have at least one nucleus, which acts as the information center of the cell and controls and regulates its activity.
These slimy amoebas can be found everywhere. There are around 1,000 known species, and they come in a huge range of colors. They live all over the world, but they prefer the warm and damp forest floor of the tropics, where they have access to rotting vegetation and can feed on bacteria, fungi, and yeast. There are, however, some species that thrive in arid deserts and the cold of Antarctica.
Some slime molds have endearing nicknames, like living creepies, demon droppings, rotting mucus, and even dog vomit. I wonder what that last one looks like. Yeah, I don't know what I was expecting, but it's not good. No.
Slime mold is a bit of a blanket term for a bunch of organisms that look and act similarly, but they can be separated into two broad categories, cellular and plasmodial. Cellular slime molds operate solo, but when they do encounter a food source, they'll put out signals to their friends and family to join the feast. These individuals will then form a mass and goo around as one, but each still remains a single cell. This type of cellular slime mold is almost always microscopic and can't be observed with the naked eye.
Plasmodial slime molds, otherwise known as myzomycetes or true slime molds, can be seen with the naked eye and act very differently when they pile on.
The most famous and well-studied of the true slime molds is the highlighter yellow Physarum polycephalum, which translates to many-headed slime.
Like cellular slime molds, plasmodial slime molds turn into a pile of creeping goo. But in their case, when they form a mass, called a plasmodium or supercell, they become one single oozing unit.
When these true slime molds band together, the cell walls between them disappear, and all of the nuclei operate as one. This mass is full of a system of veins, which are filled with a jelly-like substance called protoplasm. Wrapped around the veins are long strands of proteins which squeeze and relax, causing the protoplasm inside to pulsate forward.
It's a system of locomotion that's utterly unique and definitely kind of unsettling. Unsurprisingly, the 1958 cult horror film, The Blob, was inspired by slime mold.
Slime molds have receptors that give them a form of senses. They can smell if food is nearby and see by detecting light. They can even sense moisture and pH level. The direction of the slime mold's pulsing is in response to the signals these receptors are picking up. With Physarum polycephalum pulsating at about a centimeter per hour at room temperature, it can respond to these signals at an impressive pace.
While slime molds don't have brains, they do exhibit pretty incredible behavioral intelligence. As far as a pile of goo goes, they can act much more intelligently than researchers ever expected.
Several studies have shown that slime molds will consistently find the most efficient pathways between sources of food. One study famously placed oats, which slime molds go crazy for, by the way, in the same configuration of the major hubs of Tokyo, and the slime molds were able to almost exactly mimic the subway system.
Japan's railway system, one of the most efficient in the world, was painstakingly created over decades by the best and brightest engineers, but the slime mold managed to accomplish the same efficiency in a single day.
To arrive at their highly efficient routes, first, the slime mold fans out to explore its territory. Once it finds sources of food, it'll strengthen the most direct pathways between them and let less efficient routes dry up.
If that's not smart enough for you, they've also been known to anticipate events.
In another study, slime mold was exposed to unfavorable dry and cold conditions at regular intervals. In response, growth slowed during those periods. But before the next regular period of unfavorable conditions even began, the slime mold had already slowed its growth in anticipation of what was to come.
It actually learned the pattern of these spells and took measures to protect itself before it was hit by the next wave of dry cold. I need you to know that where I come from, it's not uncommon to see people walking around in shorts in the snow. So you tell me, who sounds smarter?
In yet another experiment, a small bridge was covered in salt with a yummy snack placed on the other side. Slime mold isn't harmed by salt, but it definitely doesn't like it. In a journey that would normally take an hour, the slime mold first needed 10 to reach the treat while navigating the salt. On each progressive day, however, the slime mold needed less and less time to cross the unpleasant salt to reach its snack. Within a few days, it was breezing over the salt in an hour, as if it wasn't even there.
Pushing that experiment further, this first blob of slime was introduced to another that had no previous contact with salt. And within a few hours, even the new blob had learned to be okay with salt. So slime molds are capable of a kind of teaching and learning, which, if you ask me, is pretty damn smart.
To germinate, similar to mushrooms, slime molds will sprout up fruiting bodies that throw spores. And these spores can travel. Genetically identical samples of slime mold have been found in both New Zealand and the US, meaning that the spores somehow managed to make it more than 14,000 kilometers to set up shop on another continent.
The ability to travel so far and wide is also an extremely smart way to make sure you never run out of territory. So next time you have the urge to call someone a brainless amoeba, just know that you're actually complimenting their intelligence. So what should we talk about next? Let me know in the comments, and don't forget to subscribe for new episodes every week. See ya! Delicious. I'm wearing a shirt made of slime. But in their case, get over here, Roomy. Room. La la la. Okay. Oh, that's cool. That's all cool. If that's not smart enough, shit. Oh my God. My cats are ruining everything. Get over here.
Didn't you see the sign that says rolling?
Okay, you tell us about slime mold, Suck. Do you like it? Do you smell that? Are those fingers coming out of the ground? It's been fun, guys, but I think the zombie apocalypse is upon us. No, I'm just playing. These are not ghouls, but they do smell the way I think zombies might smell. These are the weirdest, stinkiest fungi on the planet, the stinkhorns.